talk. My name is Pri from UCREL University Center for Computer Corpus Research on Language. UCREL is a joint research center between the Department of Linguistics and English Language and the School of Computer Computing and Communications, Lancaster University. I'm happy to host today's UCREL Corpus Research Seminar, or UCREL CRS, or UCREL Talk. UCREL CRS is a forum for all staff visiting academics, postgraduate research students, or scholars interested in corpus-based research in any area of linguistics and computer science. On today's talk, we are joined by Karlina Denistia. Karlina has just recently obtained her PhD from University of Tübingen,
Thank
Germany.
you. Yeah.
Now she's joining us live from Indonesia, which is 6 hours ahead from UK time.
7, by the way.
4 days. And the title of her talk today is, as you can see on the screen, Affix substitution in Indonesian and its impact for discriminative learning. Before I hand over to Karlina, just to let you know that this session is recorded and the recording will be accessible from UCREL CRS YouTube account, and the link will be posted on our Twitter account. To avoid any disruptions during the talk, please turn off your microphone, and during the question and answer session, raise your hand to let me know you want to ask a question and unmute yourself when it is your turn. All right, Karlina, you may begin.
Hi. Yeah, okay. Are you listening to me? Can you hear me?
Yes, we are.
Thank you very much. Yeah. So thank you very much for the UCREL talk, Lancaster University. It's a pleasure for me to share my research about Indonesian affix substitution in Indonesia and how it impacts on the learning process. This research was a part of my PhD project when I was studying in Tübingen University, Germany, and Rolf Harald Payen was my main supervisor. So let's just go on. There are 5 main sections I would like to deliver in this presentation. I will start it by the background of the study and then continue to the affix substitution in Indonesian morphology, the method, result, and finally the discussion. This research focuses on 2 Indonesian prefixes that is similar to the English suffix er, as in swim to swimmer and print to printer. However, in Indonesian, we have 2 affixes instead of only 1. They are prefixes that can express agent or instrument, and the first one is called nasal. And this is called nasal, the way how I pronounce this now and afterward, and the N stand for nasal because nasal has 5 nasalized allomorphs, which are all phonologically conditioned. In addition, nasal also have 1 non-nasalized allomorph. And the second prefix is called p. This is the way how I pronounce this, p. This prefix does not follow nasalization rule. But then what is interesting is that p and nasal are similar in form and meaning. As I exemplify here, the blue is penasal, so pelukis, pewarta, and pemurni, all of them are penasal. And as I've mentioned before, that this prefix has a similar function as the er suffix in English. So from the word lukis, that is to paint, we have pelukis, that is painter. And from warta, that is news, we can have pewarta, which means broadcaster or news broadcaster, and murni, that is it becomes pemurni, that is the instrument of purifier. And the red one shows p. This form looks really identical whenever both of them attach to the base word initialized by l, w, r, and m. And for instance, as you see here, when nasal is attached to the word initialized by l, as in lukis, it becomes pelukis. And when p attaches to the base word initialized by l, as in lari or to run, it creates pelari. And the forms are just identical. then how could one identify when to use per or when to use penasal? That is when we use this kind of the affix substitution between per and penasal. One way to differentiate per and penasal is by looking at their corresponding verbal prefix. So penasal is described as having a corresponding verbal prefix called menasal. This is the way how I pronounce this, menasal. As penasal has 5 nasalized allomorphs, menasal also has 5 nasalized allomorphs and 1 non-nasalized allomorph. And all of the phonological conditions of the nasalization are just the same. Hence, the paradigm generally works this way. If we have a base word, lukis, that is to paint, for instance, we first create the verb with menasal, and then from menasal, which means to paint, melukis, which means to paint, we can create the agent of menasal, that is penasal pelukis, or painter. And thus we could have the set of words such as mencari, to search, to pencari, search engine, or menggambar, to draw, to be penggambar, drawer. And for pa, it is not corresponding with menasal, but it is described as having a corresponding verbal prefix with ber. This is the way how I pronounce this. Therefore, if we want to identify whether pelari is pe or penasal, we should refer to the corresponding verbal prefix, whether we have berlari or melari. In Indonesian, in fact, we don't have melari. We have berlari instead. Therefore, from the derived verb berlari, which can create the agent pelari, then the pe over here is identified as pe and not penasal. Many nouns with penasal and its allomorph are derived by affix substitution from verbs with a prefix menasal and its allomorph. As listed in the table here, we have pencinta, that is who loves something, to mencinta, which is derived from mencinta, that is to love, and peninju and meninju, pengecek and mengecek, and so on. What is interesting in this one is that both words, the set of words of mencinta and mencinta, only differs in one phoneme, the p and m. And this is what we define as the affix substitution. I will use the term also discrimination or discriminable to refer to the phoneme difference. In other words, pencinta and mencinta are discriminable only in one phoneme. And in the study, we evaluated if the systematicity between penasal and menasal might facilitate learning because of its regularity. As we can see here, because they are only different in one phoneme, the p and the m, and the rest are just identical and similar. So we are curious on how this systematicity and regularity impacts the learning for penasal and menasal in comparison to p. Well, one can assume that learning penasal might be easier than learning p, because penasal has menasal corresponding form. For instance, phonologically, if one say, okay, I learned how to pronounce mencinta, then automatically, as soon as people will also learn pencinta in this case, because the sequence of encinta are just similar. That is also what is stated by the Blevin et al. Here, that regularity facilitates prediction. So we are expecting that by having the affix substitution of penasal and manasal, it might be good for learning compared to pe. Here we come to the method. The materials for this study were taken from Leipzig Corpora collection, an Indonesian written corpus dated from 2012 until 2016, and the corpus was taken from various sources such as Wikipedia, online news, or blog. And from the corpus, we choose 99 monomorphemic words containing all word classes, noun, verb, adjective, adverb, that has the highest counts of derived words. And also, there should be at least one derived word with pe or penasal is attested in those 99 monomorphemic chosen words. Then I expanded for the derived and the inflected formation. The data selection process resulted in 2,517 non-reduplicated words, consisting of 109 words with pe and 221 words with penasal. This is how the data looks like. So we classify the information in the data set based on word and paradigm morphology. In this theory, we treat a word as one unit and contains some meaning that is referred to a set of paradigm. So with this word, for instance, we treat ajar as one unit that has the meaning or the paradigm of, okay, it is inanimate and abstract, and then pengajar is ajar, that is and concrete and agent. Thus, the addition of penasal over here has the impact in changing inanimate to animate, the abstract to concrete, and it also adds the agent of meaning. We did not treat pengajar as the segment like what the common morphology did. Like, okay, pengajar derived from penasal plus ajar, like a classifier. No, because because this theory believes that we are learning the word as one unity, as the word and all of the meaning, from examples, from paradigm, and from not from the segment. We're not taught since the elementary school, we're not taught that if you want to create an agent, you should add penasal. No, we were taught that in the university level, but throughout the learning process, we know that, okay, additional of penasal will change inanimate to animate, abstract to concrete, and will also add the agent. And to simulate the learning process, we may use a computational model. So it is a combination between the corpus study and the machine learning study as well, using the computational modeling called the discriminative lexicon, introduced by Bayan et al. 2019. The model accuracy was measured in two networks. The first one is comprehension. And in the comprehension learning, what we feed to the model is the trigrams of the word. And with this feeding of the trigram, we expect that the model would be able to predict the semantic of the triphone. So in other words, if we feed the model with these sequences of triphone from pengajar, hash PE, the hash here indicates the word boundary. So it's initialized by hash PE, PEA, EAJ, AGA, GAR, and AR hash. With this sequence, we want to predict the model to predict this paradigm of the meaning for the sequences of triphone. That is how the model comprehension was attested. And for the model production, it works the other way around. So we fit the model with only the semantics meaning of it, and we want the model to predict the word form. And in total, out of 2,517 words, we have 852 trigrams to be attested. Here we come to the result. Our model accuracy is 94%, both in comprehension and production, which is quite high. And this is the subset of our model comprehension result. The lexeme is the base word, and the form is what the model predicted. And the target word is the gold standard, the cue that I gave to the model. The rank shows which rank is the predicted form taken place, and the correct give whether the model prediction is correct or incorrect. And R here means the correlation value. And this value measures how close is the gold standard to the model prediction. And the rest are the paradigm that I give to the model. In this part, we see that the model, in this only simple subset of comprehension result, we see that the model predicted 2 words incorrectly. The first one is pedagang, and well, the target word is pendagang, but the model predict that to be pedagang. And the second mistake is pendatanya, but the model predict to be pendata. In this case, I can explain this that these mistakes are linguistically make sense, but this is not the thing that I'm going to explain more in this presentation. And this is actually for the production data set. As I've previously mentioned, that in the production level, we give the model the paradigm or the semantics paradigm, and then we expect the model to predict the form. And this target is actually the target words, and the predicted one is the predicted form. And here we also have the correlation value and also the information whether the model predict the word correctly or incorrectly. Interestingly, from this sample and small set of the result of the comprehension and the production, when the comprehension made 2 mistakes, well, the production makes only 1 mistake. So pendagang is now predicted correctly in the production. Now, here is the result of how pe and penasal are learned by the model, because going back to the previous research question, considering that penasal has the affix substitution of menasal, how it impacts to the learning. And this box plot shows the mean of the correlation value as the measurement how close is the gold standard to the model prediction for words with pe, shown in the red one, and penasal, shown in the blue color. As shown in the y-axis here, the higher correlation means that the more precise the model prediction to the gold standard. And the left panel shows the comprehension, which means that this is the precision of this semantics meaning prediction. And on the right panel shows the production result or the production correlation value, in which in this production, it shows how precise the model predict the word's form. A Wilcoxon test clarified that pe is predicted better than penasal. It is shown by the higher mean correlation value for the red one, that is pe, compared to the blue one, both in comprehension and in production. And it should be noteworthy that removing menasal from the training data will make the difference no longer significant. In other words, This difference with the p-value less than 0.0001 for all the comparison occur only due to the presence of nasal in the data training. What happened? What is the influence of nasal? Why nasal makes nasal to be less precise in model prediction, both in comprehension and in production? The first reason is that in the model, it turns out that the phonological similarity between panasal and manasal drives Q competition. So, as illustrated in the table here, for instance, we have the word pengajar, which is teacher, and mengajar, which is to teach a lesson. And these two words for pengajar and mengajar are broken down into several sequences of triphone, and it turns out that these two words are only distinct in two triphones, the hash PE, PEN, and the hash ME and MEN. The rest of the triphone are just shared, and that occur not only for pengajar and mengajar, but also for all of the words that has a corresponding penasal and menasal noun and verbal affix substitution, such as in pencinta and mencinta. They only distinct in two triphone, and the rest of the triphone are just shared. What happened in the shared triphone is that as a consequence, the shared triphone cues has to compromise this one. These are the shared triphone. Whereas for the menasal, it has the meaning of the verb paradigm. And for penasal, it has the meaning for the noun paradigm. So the shared triphone cues has to compromise between the verbal and nominal and verbal and nominal, depending on only whether the word is initialized by p or ma. And this cue competition make the precision on the prediction of penasal becomes lesser. And if I can make an analogy, it's probably like discriminating crocodile and alligator. Too many shared features, too many similar features between alligator and crocodile, so it's harder to discriminate or differentiate. However, for nouns with p, with their corresponding verb of ber, such as in pecinta and bercinta, they share less similar triphone compared to penasal and menasal, and they have more distinct triphone for the model to learn. This then drives a better learning in the model, because by principle, the more discriminative cues a word have, then the better the model will learn the word. And this study shows that apparently the process of affix substitution between penasal and menasal turns out to be a little disadvantage for model learning, both in comprehension and in production. The second reason why p is learned better is because p attached to more inflection. As shown in the table here, that the word in the data set of p is only 100 something, and for penasal it's double to 100 something, but the mean length in character for p is significantly longer than the mean length in character of penasal. What I mean by character here is I just counted how many letters are in average for all of the data set that I have for word with p and penasal. And it turns out that p has a longer word in mean compared to penasal. So the fact that p has a longer word than again, it still holds that the longer the words, then the more discriminative cues that the word has. It means that also the better the model will learn the word, because there are more distinct triphones that the model can learn from the data set. Finally, I hope that I have shown that the computational modeling with linear discriminative learning revealed the predicted form and meaning showed stronger correlation for P as compared to P-nasal for two reasons. The first one is because P-nasal has a Q competition with P-nasal, and then the second one is because P-nasal has shorter character mean average compared to P. And the finding that P-nasal is learned less robustly than P due to more extensive Q competition when substitution pairs are phonologically similar suggests a possible reason why affix substitution is relatively rare both within language and across Austronesian languages. Finally, thank you very much for listening to my talk, and I'm really happy for question and discussion. Thank you.
Thank you very much, Karlina. And that's just like 27 minutes, so we have a lot of time for question and answer. Go ahead if you have any questions for Karlina. Is there any question?
Yeah, I see Raising Paul. It's raising.
Go ahead, Paul.
Hi, thanks for the great talk.
Hi.
Hi, really interesting stuff. So I wondered on the trigrams, the character letter trigrams that you've used in the model, whether you investigated other lengths of n-grams, say longer than 3 characters, to see whether that improved the prediction at all for the where it was making errors.
Well, we're still examining and investigating on the word level. It's not yet on the compound. So do you mean with the n-gram is like you broaden the windows of the word to like one word to the left and one word to the right? Is that what you mean?
Possibly, or you just use more characters within the word. Yeah, I mean, possibly to look to the left and to the right as well beyond the word boundary might help. But I wonder whether 4 grams or 5 grams might the prediction improve better.
Yeah, so I tried to the 4 gram, but not on the 5th gram already, because the model performance was worse when I tried to the 4 gram. So I stick on the trigram instead.
Ah, interesting.
Yeah. So the model, that's interesting. And I think the reason why is because we have P-nasal and then plus the base word, and the boundary there is more precisely captured in the trigram, like the en base word, enx, and then nx ey for the trigram, and for the 4 gram it might not be that informative, I suppose, because the model performance decreased like 10%, if I recall that right, with the 4 gram.
Right. Okay. So it's going beyond the useful set of information. Yeah. Okay. Thanks.
Okay. Thanks for the question.
Thank you very much, Paul and Karlina. And Karlina, we seem to have one question from the chat box. Can you access the chat box?
I do.
Because you're using browser now, I suppose.
I can. No? Yeah. Do you have any ideas for Indonesian researchers interested in morphology and similar topic to yours? I do, actually, because that is from Arina Istiana, right? This is for P and P-nasal that are pretty similar in form and meaning, so that I'm just curious on how their learnability is different. And in Indonesian, we still have much more ambiguous prefix or affix suffix, circumfix, right? For instance, we have that. I will write that in the chat box. Stir can mean abilitative, incidental, and also superlative. To my best understanding, one prefix can have more than one meaning, and I'm curious in how to apply this to our model, seeing this from the word and paradigm morphology, and see how the model can learn and deal with this ambiguity. Whether, I don't know, it's just an explanatory research, so I might need to read more for the hypothesis of this one, but I'm really curious in applying this model to another Indonesian prefix or suffix or circumfix. Yeah.
Right, thank you. The question, by the way, is do you have any ideas for Indonesian researchers interested in morphology?
Yeah, so we can apply this model as well. And if you're interested, we can have a collaboration, or we can formulate a kind of a research question as well on how this model can deal with the affix homonymy or affix ambiguity.
Right, okay.
Yeah.
We have another people with hand up. Gede, go ahead with your question. You can unmute yourself.
Check.
Yeah,
yes.
I hear you, Gede.
Well. Okay. Thank you, Karlina, for the presentation. I enjoy it. And my question is that, I don't know, maybe this sounds naive, but I would like to know if the idea of learning here also transfers into real learning by human, you know, whether human or students or learners will learn those prefixes, whichever they are, more easily than the one that the model finds to be more difficult. Is there any, you know, transfer or correlation between modeling learning and real learning? I think that's it. Thank you.
Really interesting question. So modeling with real human. Okay, yeah. So for the real human learning, I think we should do a kind of an experiment for the cross-validating data, right? But what is interesting is I can share you, hold on. What is interesting is that the model error is to some extent linguistically makes sense. And we as the native speaker of Indonesian can also see that, yeah, we somehow made a mistake in that model mistake as well. I can show you some of the mistake that the model made. Wait a moment. There we go. I hope now what you're seeing is the PDF of my dissertation. Are you seeing my PDF of the dissertation?
Yes, we are seeing a PDF.
Perfect. So in the table 5.5, for instance, this is the comprehension error involving pe and penasal. The first one, and what is interesting is here, for instance, when we have the word pendagang, I could not make it highlighted. Now I should. Okay, this pendagang, the targeted form is pendagang. I was a bit surprised when the corpus shows me this word. Like, okay, so there is a word called pendagang, and it means the instrument to carry stuffs on the shoulder, and that's pretty new for me. And what the model predicted is not pendagang. the model predict that to be pedagang. And that is, yes, I think Mbak Arina and then Gede and Mas Prihantoro will also will be surprised that there is a word called pendagang here and the model predict. And at the first time I found that in the corpus, I was like, this might be a typo. This could be pedagang or seller. But then it turns out, yeah, that is the word called pendagang. And then the second one is the model error in having the word penyertanya to be pesertanya. That to some extent, we also sometimes mix. That penyertanya means someone who comes together, and pesertanya means the participants. But I find out that penyertanya is to some extent low frequency word, and pesertanya is more highly frequently used in the corpus. So yeah, the model predict that to be pesertanya. And then the third one is pekasih, that is love potion, and kekasih, that is one's. So the model predict pekasih to kekasih, one's beloved. And the explanation for this is that pekasih is actually pe. It is not penasal. So pe can express a patient. Like for instance, we have pesuruh. Some suruh is to commend, and pesuruh is to be commended. Someone who is commended. And pekasih, in this term, what I might expect is okay. So what the model might think, okay, pekasih is the patient, so that I should refer to the patient. Once beloved is the patient, so it could be kekasih. So this kind of the error is to some extent for me interesting today. So yeah, in other words, I could not assure whether this computational modeling will be reflected in the human modeling, but me seeing the data and seeing the result of the prediction of the model, it's just interesting that the model can to some extent predict that correctly, but with the error that linguistically makes sense. Okay.
Thank you,
Karlina.
Yeah, you're welcome.
Do we have more questions?
But
I mean, sorry.
So that
yes.
I find it interesting that the error still semantically related to the one that you predict. You know, like the pedagang and pendagang, they are all related in one semantic domain of selling. But in any case, how their error is also interesting.
And their error is also a word. I mean, they're not making the novel thing like out of nowhere. They're still a word. Yeah. And as I previously showed you, that actually the model also gives the rank. And surprisingly, the rank of the predicted form is included in the first 5 rank. So like, let's say tinggi to peninggi, peninggi is actually the second rank. But then the first rank is something else. So this one, for the targeted form that is tinggi, the model predict that to be peninggi, and this is the first rank in our model. And then the word tinggi itself, which is the targeted form, is placed as the second rank. And for pendagang, the model predict that pedagang, and this is placed as the first rank. But then pendagang itself, when I take a look at the model prediction and the rank prediction, the word pendagang, which is the correct one, is placed as the second rank. So I think with a bit of modification in the coding of the model, maybe we can push the second rank to the first one. I don't know. We'll see. Yeah.
All right. Any more question or maybe responses? I think it's quite interesting, the word pendagang. I have never heard of that word before.
Me neither.
Look it up on the dictionary, KBBI, and I found it, which whose meaning is exactly the same, like what you saw in your class. Yeah, but I think morphologically it's not that surprising. That form is morphologically possible because the root or the lemma that starts with D tends to have an nasal allomorph instead of prefix without an, as in pedagang.
Yeah.
Right. Gede still raising hand. Gede, do you have some more things to elaborate? Or you just forgot to lower your hand? I don't know.
He's now lowering his hand.
Right. So we still have a lot of time. We still have like maybe wait, I think we have 18 minutes. Maybe you want to clarify some or more things from your presentation? No?
Yeah, I think that's all I just want to say, because if I expand this into another one, that's going to be another topic that is related to the functional load, and that might take another 40 minutes, I suppose.
Okay. Let's do that now.
Not really a good idea to be conducted now.
Only for 1 hour.
Yeah.
By the way, can you show me the box plot on your presentation?
Yeah, sure. So are you seeing the presenter mode?
Yes,
or
this is power. Right now, this is presenter view.
Okay.
The box plot is in, I don't know, I think 14 or 15, if I remember it correctly. Oh, more than that. Right. So there are some dots outside of the whiskers. Are they outliers?
They are outliers, but I haven't. Yeah, I haven't checked that. Maybe those are the errors, I think.
Right, but they are quite. Do you think that their numbers are quite significant?
Well, the number that is significant is the mean difference comparison.
Okay.
So the difference between this and this plot, this line. I don't think you are seeing my cursor. Okay. So are you seeing the blue laser?
Yeah, I'm seeing that.
So the difference, the significant difference is happening here, the mean of the per correlation and the mean of the penasal correlation over here. So it's just a little, I suppose, a little different, but they are significant. And this is significant only if penasal is put into the data training. When I take all of my nasal words out, the box plot remains the same, but it's no longer significant.
Okay.
Yeah,
I'm just curious about the outliers because they seem to be quite a lot from here. I don't know.
Yeah, well, there are some 1, 2, 3, 4, 5 of them, I think,
right,
with a low correlation value. Yeah.
Okay.
I can share it to you if you're curious what the words are over there.
Maybe later, not here.
Yeah, sure.
Right. We still have 15 minutes.
Yeah.
Questions from anyone, maybe? Or maybe you want Karlina to clarify some of the slides?
Yeah,
her presentation, just in case maybe you missed some of them.
Right.
Yeah.
Yeah, I just wonder if my explanation about the discriminative learning is quite clear or not, because this kind of a discriminative learning is developed in my PhD research group, and they give the ideas that learning is a set of the process in discriminating words or discriminating and distinguishing and finding the difference of the element of not only the word but also the syntax, the pragmatics or the sociolinguistic or the environment or the context, and all of the other language element. And the idea of this discriminative learning is to some extent maybe new for some people. So I hope that I explained this idea of discriminative learning pretty clear. If not, then please ask me to rephrase that again. I wouldn't mind.
All right, we seem to have one question in the chat box from Mita.
Oh, okay.
Respond from Gade, I think.
Uh-huh.
Can you see them? Or
I can. Is there any literature that you can recommend us to learn or study the basic of Indonesian affixes? Oh yeah, James Nails Nedden. Those are pretty comprehensive. I can share that to the chat room. Okay, that is one that I used. And the other one, some papers. I can get back to you and give you some references. Mita Pristanti, thank you for the question. And from Gade, doing an experimental study. I'd love to. Yeah, for sure. Let's decide that carefully.
Another question from Mita.
Is there any semantical explanation in that book? Not really. For the semantics analysis, well, they explain the semantics analysis qualitatively. So let's say, for example, they just mentioned that "pe" is the prefix to express agent or patient, and "penasal" is to express agent or instrument, and that's all. But using the quantitative semantical analysis, we need to refer to Gade's paper, for instance, or my paper for "pe" and "penasal" that has been accepted but not yet published. I can share you the draft of it as well. I don't mind. I hope Harold Payan will not also mind. I need to ask for his permission first. And the semantical explanation in that book is just only the descriptive overview and the general semantics, but not to the specific function of the semantics using the quantitative data like what I did and what Gade and what Mastri maybe mostly did as well. Okay.
All right, so maybe it depends on how Mita defines semantic. Semantic define qualitatively or quantitatively. If what she meant by semantic is qualitative semantic, maybe that book will suffice, I think. Yeah. Or at least as a start.
Yeah. So that book gives the qualitative semantics, yeah.
Yeah. And there's also a book written in Indonesian, Tata Bahasa Baku, Bahasa Indonesia, like Indonesian reference grammar, but that's pretty old. It's quite hard to find the printed edition, I think. Yeah. Because it was printed first time, if I remember it correctly, in 1980s, and it's the last printing was in 1998. So I don't know. Right. Yeah, it's quite hard to find. Right. Okay. So any more questions? We still have 10 more minutes.
So how is your lab? Do you do in your lab, do you do a kind of a computational modeling like this with the corpus linguistic as well, or you're doing something else?
Maybe Paul can answer this question.
Yeah, I mean, we have half of the group would be based in the computer science area, so in School of Computing Communications, and we do a lot of NLP work. Nothing particularly on morphology really at the moment. But yeah, people are working on a variety of things. So large scale analysis of, say, mental health discourse, or building named entity recognition approaches for African languages, sentiment analysis, a variety of things, but nothing really similar to what you're doing here with Harold.
Yeah. The mental health discourse, what are you doing with that? Are you doing an experimental design for that?
Yeah, that's with people in health and medicine faculty here. So there's the Spectrum Centre that has worked on bipolar for a long time, and so we're working with them on doing a corpus and NLP analysis of how people talk about bipolar, in particular, two areas: personal recovery and risk, kind of discourse about risk. So yeah, there's a lot of crossover now between CAS, UCREL, and the mental health area, and health and medicine in general. So people like Paul Baker's worked on that as well, and others in CAS on modelling of language around medical discourse.
All right. Which corpus are you using in order to investigate that?
Karlina, sorry to interrupt, but there is a question for you, I think.
Sorry, it's interesting.
Sorry, Paul. Maybe we can
continue later.
Research short, we can do it a bit later. So there's one question from Sunarti in the chat box.
Yeah.
Can you see the question, or should I read it for you?
Well, I can read that actually. Is your research discussed about the meaning of affixes? If you do that, how do you find the meaning of the affix? Another from the sentence, I mean. So I find the meaning of the affix from, first, the literature, what they have described qualitatively, like the Snedden et al. Described in another paper. First, that's the first one. Then the second one, I check that against the Indonesian Comprehensive Dictionary, or KBBI, Kamus Besar Bahasa Indonesia, the digital version, to clarify whether the meaning is still up to date or not. And then the third one, I also check that in the usage corpus space. So I'm looking at the sentence and seeing the context, and then defining what the meaning of the words with that prefixes are. So 3 stages of the classification in the meaning. Yeah, that's what I did for my research.
Yeah, thank you very much. And I think that answers the question from Sunarti. Or do you want to follow up that, Sunarti? Maybe not. Okay, so question answered. And so talking about mental health, there is going to be a talk at the end of this term by Luke Collins and Elena Semino. And the title is Triangulating Corpus Linguistics and Clinical Psychology in a Study of Narrative of Voice Hearers. Right. So
I'm looking forward to it. So
research, I think, because they also presented in UCREL previous term. So this will be interesting to see how the research progress.
Exactly. That would be fascinating. Yeah. So that will be updated on the website of the UCREL. Right?
Yeah. I'm going to update it with the abstract as soon as I have one.
Yeah.
But the schedule is there, and I will send the invitation on UCREL mailing list and Twitter and some other media perhaps.
Thanks.
Right. So what time is it in Indonesia now? I think it's almost 10
10 p.m. Yeah.
Right. So I think let's cut it here and call it a day for Karlina. Gede said it's 11. It's already 11 p.m. in Bali.
Call it a day for
Because Bali
Gede.
is on different time zone, like yeah, another time ahead of from Karlina's, where Karlina is now. Right. Thank you, Karlina, for giving the talk. And I believe there might be more questions, but we are scheduled only for an hour, and I do not want to prolong the session any longer because due to the time difference, it must be already very late. Yeah, where Karlina is now. So if you still have questions or want to discuss something with Karlina, maybe you can email her. Her email is available in. Is it available in your presentation? Or
it is, yeah, in my first slide.
Okay.
Yeah.
And for the next UCREL talk, we will be joined by Gede Primahadi Wijaya Rajek. He's also here, actually. The abstract of his talk is available at UCREL website. Right, thank you, Karlina, and everyone in this talk. Really appreciate all of you coming here and looking forward to seeing you all again in the upcoming UCREL talks. See ya. Bye. Let me turn off the recording. Yeah.